Okay, 18 packets of water cement had their contents measured for weight. The markings on the packets indicated that the weights are 150 kilograms each. The measured weights are shown below. Okay, so colleagues, remember these companies that package goods, they will tell you 50 kg or 10 kg, but when you go home and measure, you find there are discrepancies. Okay, so out of 18, we get a sample of 1, 2, 3, 4, 5, 6, 7, 8. Okay, we've got our sample. We get 8 bags and we've measured them, and these are the weights. Calculate and estimate number one, the population mean, then also the population standard deviation of all the cement of the Dangote brand. So, colleagues, we'll be working with this sample here of these 8. Okay, so we have to get the mean. So, what are we supposed to do to get the mean? Yes. Okay, so mean equals summation of x divided by n. So let's add the weights. $898.2. Colleagues, are we all getting 898.2? Hmm. Hmm. Those are, yes, 1197.7. Madam, what is happening? 1197.7. Then if we divide by 8, we get 149.7. That is, yes. Are we all getting this, colleagues? So you're answering for everyone. Maybe the others who haven't got. Okay. Okay. Wonderful. Now we get the standard deviation. Okay. So this is the formula for the standard deviation. So each value, we're going to subtract it by the mean. Okay. So remember, these are the weights here. So you start 148.8 minus 149.7, you get this value. 149.5 minus 147, you get this value. You're just subtracting each of the means, each of these weights, you're subtracting it by the mean. Are we okay with that, colleagues? That's how I got these values here. As you can see, x minus x bar. No, 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 no. Minus the mean, x 149.7. So all of these you subtract, minus 149.7, minus 149.7. All of them you subtract. Then, after you subtract, each value you're going to square. eh, it's the ones we're evaluating. Yes, yes, yes. Colleagues, do not. Yes, yes. Here, yes, they've said 18 packets, but we're looking at 80. So do not use 18 and you're just dealing with 80. Okay, you're dealing with this 8. So for all these questions, n is going to equal to 8. Any questions before I move further? You square each of these values. After you've subtracted each individual value by the mean, then you square the value. Okay, okay. So these values which I've highlighted here, you square them. Okay, you square each of them. Once you square them, you total them up. Okay, so we've added all of these here together. 0.83266 plus this plus that, we get 1.0 1.6088. Okay, we've subtracted, square, and after you square, total up. After you total up, now you can use this formula here, standard deviation. S equals summation of x minus x squared. We've already got that value. It's this one divided by n minus 1. So 8 minus 1, that is 7. So 1.6088 divided by 7, what do we get? I think it's this value here. 1.6088 divided by 7. Colleagues, are we getting this? 0.2982? Okay. Okay. Yes, yes, I've seen 2290. Then what is the square root of 2298.2? Okay, you can round it off to 0.48. Yes, that is our standard deviation. Any questions? Part B. Construct a 99% confidence interval of the mean weight of the Dangote cement. Colleagues, what is a confidence interval? This is the range in which you find the true population mean. Okay? It's the range in which you find the true population mean. That's what the confidence interval is. Okay? So, this is the formula. Confidence interval, it's the average plus the plus or minus the margin of error. Colleagues, what is the margin of error? The terms are coming in now. You wonder, all these terms. Basically, margin of error is like the room for error because our sample mean or our sample estimate, okay, we're giving it some room for error, okay, room for adjustment because that sample estimate is not exactly the same as the population estimate. There might be a discrepancy, okay. Your sample mean and your population mean, they can be different. So there's like a discrepancy there. All right. So that's the margin of error. Just say it's basically the room of for error for your sample estimate. Okay, so this here, this T whatever alpha over 2, this represents our critical value. Okay, our critical value. Now remember here, whenever your sample size, if n is greater than 30, you're using your Z tables. So here in this formula, that would be a critical value for our Z table. But if your sample size is less than 30, then you use T tables. Okay? So here our sample size, since we're using 8, it's less than 30. Okay, so we're using our T tables. Okay, so we need to first get our critical value because we've already got our mean, we've already got the standard deviation, we've already got the sample size. All we need is to get our critical value from the T tables. So the way we get critical value from the T tables, you say first you need just two things: your degree of freedom and your confidence level, or even your significance level, whichever is given. Okay. So for here, so 99%, so it means our confidence level is 99%. We're 99% sure that our population mean will be found in this range. Okay. So for the degree of freedom, remember it's just n minus 1. Okay. N minus 1, that gives you 7. Okay. Then you go to your T table. Okay, this is a T table. You look, okay, where is my confidence level? Here, 99%. You transverse it up and you say, okay, now where is my degree of freedom? Degree of freedom is 7. So our critical value here is 3.499. Okay, colleagues, just get your degree of freedom and find your confidence level. Then you say, okay, so confidence level 99%, degree of freedom 7. So our critical value here is 3.499. Any questions? Okay, so confidence level here 3.499. I mean, our critical value 3.499. So now we can calculate our confidence interval. So X bar is 140. What was our mean again? 147.9. Let me just check here. 149.7 plus our critical value 3.499. Our standard deviation, which is here S 0.48, divided by the square root of our sample size, so square root of 8 here. So let's start. What is the square root of 8? Square root of 8. 12 point, 2.8, 0.48 divided by 2.8, 0.17. Okay, 0.17. Oh, this has to be plus or minus. 0.17 times 3.999. Just 0.6. Huh? Okay, so remember our confidence interval has got an upper limit and a lower limit. Okay, so for our upper limit, we're going to say 149.7 plus 0.594. What do we get? Our lower limit, say 149.7 minus 0.594. What do we get? 149. Okay. So the true average, mm, when we did this tabulation here, yes, when we got when we divided 0.48 times 2.8, we got, I think, point. What did we get when we? Whatever number you get, then you multiply by 3.499. That's how we got the 0.594. 0.17 hens. So 0.17 multiplied by 3.499. 0.17 times 3.499. Okay. Oh, it's rounding off because others we did 0.171 something. Okay, yes. So that value you get, madam, you add it to the mean and you subtract it to the mean for you to get your upper and your lower limit. So This is the range in which we find the average for the population. So between 149.1 and 150.294. Okay. For all those 18 bags of cement, if we measured all those 18 bags of cement and we get the average is going to be between this range. Questions. So kindly mute your mic. Mute your mic. Okay. Part C, we're conducting a hypothesis test now. Test the hypothesis that the mean weight of a package of Dangote cement is 150 kg at a 5% significance level. So let's see those who remember what we did last time. Colleagues, what is the first step for a hypothesis test? And everyone was there, so let's not be quiet. I remember who was there. Okay, I remember who was there. Mr. Emmanuel, you are there, sir. What is the first step of a hypothesis test? Mr. Foster, Mr. Victor, colleagues, Madam Sylvia. Ish, this is scary. This is scary. Ish, 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 ish. Okay, the first step of the hypothesis test is you form your now and your alternative hypothesis. Colleagues, what is a now hypothesis? The now hypothesis is basically what is the general belief or what is accepted, basically. Okay. So here, our now hypothesis is that the average, the weight, the average weight of a bag of cement is 150 kg. That is our now hypothesis, which is labeled as H1. Okay, so this is basically just saying here the mean weight of a packet of Dangote cement is 150 kg. This is your now hypothesis. The now hypothesis will be it will be worded in the question. Okay. So now, what is the alternative hypothesis then? Yes. So what is the opposite in this case? Thank you, madam. Yes. So we are going to have a two-tailed test here. Okay, because we're saying it's not 150. It can either be less than 150, so it can be greater than 150. So we have a two-tailed test, meaning in our test here, we're going to have two rejection regions. That's what a two-tailed test is telling us. You're going to have two rejection regions. Okay. Yes. What is step two? Or before we go to step two, any questions on step one? Your null hypothesis will be usually there in the question. Okay, you do not have to think of wording it by yourself. It is there in the question. Okay. Then your alternative is just the opposite. What is step two, colleagues? Madam Bertha, Madam Yvonne, Mr. Vincent, you are quiet today. Is Mr. Vincent in? I saw him earlier on. Yeah, he's been kicked out. Yes, Madam Yvonne, what is step two? Step two, get your test statistic. Okay. You get your test statistic. This is the one that we're going to compare with our critical value. Okay. Sometimes one can start by getting a critical value. Remember, colleagues, with 95% confidence level, okay, how have I got the 95% confidence level? How do I know that my confidence level in this test is 95%? Yes, 100 minus 5% level of significance. Okay, so the level of significance is 5%, so your confidence level is just 100 minus the level of significance. Okay, basically your uncertainty, because you can never be 100% sure. So our confidence level is 95%. So what's the critical value for a 95% confidence level? Do we remember this number 1.96? Yes, I even showed you how to get it. Okay. So basically this 1.96, since it's a two-tailed, so it's negative 1.96 and positive 1.96. Okay, this critical value separates the rejection and the fail to reject region. Okay. So our test statistic is going to be compared to these. Okay. So let's get our test statistic. Okay. So mean weight is what is 149.7 minus 150 divided by our standard deviation was 0.48 divided by the sample size, which is 8 square root of 8. Now I believe earlier on we did this tabulation. Square root of 8 is 2.8.48 divided by 2.8, 0.197, 0.17. Okay, so in our denominator, we know we've got 0.17. Okay. 149.7 minus 150. 149.7 I think that should be zero point 0.3, negative zero point 0.3 if I'm not mistaken. Is it negative 0.3? Okay, negative 0.3 divided by 0.17, negative 1.764. Excuse me. So this negative 1.764, we're going to bring it here. Is it greater than negative 1.96 or is it lower? So this, so it will come somewhere here, right? So it falls in there, fail to reject now hypothesis. Fail to reject now hypothesis. Okay. So meaning we are accepting this now hypothesis that the average weight is 150 kg. Any questions?